Good day, everyone. I am Oko Olayinka Sunday. I'm presenting Introduction to R for Biological Data Analysis. I specify this for biological data analysis because many of us as biologists, when we hear something like R, we feel that it is only for those in statistics or mathematics. Unknown to us that we can learn this thing and do it ourselves. Turn our data around, play around with it, and we see a lot of relationships and make a lot of inference. And that is the brain behind this training. And the reason why it was specified that is for biological data analysis. Now, I've before now explained to us or given us some guidelines on how to install R and RStudio. R in itself, the console of R is not too user friendly. It's not too user friendly. That is the reason why RStudio is important for us. Now, this is what you see in the R console. As you can see, there are nothing to click about here. There is no icon to click. Everything is about command. Just type, give computer instruction, and that may not be too okay for people like us who are biologists. And that's the reason we have what we call interactive development environments, IDE, of which RStudio is an IDE for R itself. So we don't need to write much code. Rather, with RStudio, most of our work will be done easily or relatively easily. I've also given us some guideline on how we can install RStudio. Now, there are a lot of reasons why data analysis is important. We don't need of me going over that at all. Usefulness of R. Well, we can do that ourselves. Try to see why is R important these days. The same thing with Python. We can try to just uncover that it's good in data mining and manipulation in this era of big data. It's versatile. The visualization in R is very powerful. The same thing with Python. So that's by the way. However, we need to be meticulous. We need to persevere if we really want to get the best out of R. That is the truth of the matter. And with someone guiding us or putting us through all the trial and error method I use myself, you won't find yourself doing much of that. Now, before we start, a little statistics. We know we have what they call data types. Data types are we have numeric or integers. They will talk about categorical variables, talk about character, then Boolean or logic variable. When we talk about numeric variables, these are data set or elements you can perform calculation on. But on factors, you cannot perform calculation on them. It's like saying treatment group plus in the induced group or control group plus. No, there's nothing like that. You can't perform calculation on that. So those are categorical variable. No, male, female. You can't say male plus female equals to male. No, nothing like that. So those are factors. The same thing when you talk about character. Character, you can't say A plus B equals to AB. No. Of course, we know in mathematics we can say A times B equals to AB. That is because we have assigned some values to A and we have assigned some values to B, and then we get that type of results. Now, the data type that will be of interest majorly to us for now should be integer, which feeds we can perform calculation on, then factor, which stand for categorical variable. Then we'll talk about Boolean to see whether two things are equal or not, or whether they are greater than each other or not. Now, data structure. We have real data structures in R. We have vector, we have matrix, we have list, array, and data frame. Now, list is a one-dimensional data set. It's one-dimensional. Now, look here. You will see I'm saying students. For students, I say students equals what? We have the names of my students. We have Yinka, I have Abubakar, I have Uchi, I have John. Now you see that all of them, each of them, they are in inverted comma or in quotation mark. Come to the same thing, gender. You can see I said gender. What do I store in gender? I said store for me female, male, female, male. Okay, I come to score. You can see in score now, I didn't put anything like inverted comma quotation mark. You can see because 75 plus 67 is possible. 50 plus 67 is possible. 50 plus 80 is possible. But look at this again. BCH, biology, pharmacy, zoology. I can't say zoology plus biochemistry. But no, nothing like that. Now, I have informed R that yes, I'm storing all these names in this variable students. So join them together for me, all of them, join them together. That is this C, concatenate. We still get to that, concatenate. So when I now tell R, remind me, what are students? It will tell me students, it will output Inka, Abubakar, Uche, John, because I've already declared it to him that this is what I know as students. The same thing when I declare score. When I ask him to give me score, he will give me what I have declared into it. So see students as what you have given to R as your data sets. And data R can now give it back to you if you want to perform calculation, want to do some mathematical analysis or statistical analysis on them. Now, what we are saying here is a type of data structure called vector. You can see that each vector contains a definite or a specific type of data, not multiple types of not multiple data types. No, specific data type. If it's integer, it's integer. If it is categorical variable, it's categorical variables. If it is what do you call it now? Strings or character, is that character. That is for vector. Now let's go to matrix. Matrix is a two-dimensional data structure. Now forget about what you have seen here. I was just trying to use R to get some numbers, number 1 to 30, so that I can now use those numbers to generate a matrix for you to understand what a matrix is. So what will be of concern to you is here. Now you can see here, this is a matrix here. This is a matrix. So matrix is a two-dimensional data structure. Vector, remember, is a one-dimensional data structure. Matrix is two-dimensional. You have the rows and you have the columns. You have the rows and you have the columns. But one thing about matrix is that the elements in matrix are the same, just like a vector. They are the same. It's either they are all numeric together, or they are all character together, or strings together. They are just the same thing. The only difference between vector and matrix is that vector is one-dimensional, while matrix is two-dimensional. Now, data frame. Data frame is like matrix. Data frame is also two-dimensional in quotes. However, it can contain multiple data types. Like you can see here, on this first column, I have students, Yinka, Abubakar, Uche, John, which are all strings. We call them their strings. The same thing with departments, they are strings. The same thing with gender, they are strings. Gender here now, yes, we can call them string, but they are actually vector factors. That is categorical variables. Also, we can call this one also, they could be categorical variable. That is the department. They could be categorical. Yes, they may not be categorical. Now, scores are not categorical. They are numeric. So you can see that data frame contains multiple data types, but matrix does not contain multiple data type. The same thing with vector. Now, we are coming up gradually. For you to analyze your data, data organization is key. It is better you take time to arrange your data very well than for you to later come back, because you can, for you to be having problems analyzing them later. So take time, arrange your data very well. Now, for data frame, each column will stand for something unique, for a particular character. Look at this. This is a group. Now in this group, we have group A, group A, group A. Now, group B, group B, group B. You can see here, let's say we are using animal for this experiment, for example. This could be animal, this could be plants. Let's take for animal. For animal, we say this, that means in this group A, there's a particular type of treatment we are subjecting them to. In this group B, there's another part of treatment we are subjecting them to. The same thing with group C. And I say, okay, group A, what do they belong to? Any other character or thing peculiar to each of the animals we are talking about. We now want to look at animal one. When you are, for those of us in biology, biochemistry, when you are performing some animal experiment in each group, you could have 5 animals or 10 animals. So animal A1, A2, A3, A4. So their data for each one of them now is what we now record here against, under whatever parameters you are determining. This is like plants, so we want to look at cassava, look at the relationship between cyanides in cassava and the hematological parameters. So we now say, okay, we want to look at the quantity of cyanide in that cassava. That is what we recorded here. This is a pseudo data. I just generated this myself, pseudo. Now, this is the cyanide contents of each of these cassava. Now, this is the yield we have. This is the yield in the cassava. Let's say the yield in tons. Now, maybe we fed that cassava to rats or to any animal model. We now want to look at the PCV of that animal model. That is what we are recording here, the PCV of each animal. Now, look at the hemoglobin, we record there. MCH, we record it. We look at their weight. The same thing, anything you are looking at, you record them like that. So this is what you import to R for you to perform your analysis by and by. Now let's come back to R. In launching our R, normally you go to launch your R. Let me start with R first. To launch your R, you come to the Start button on the maybe lower left hand side of your system. Click there and type R. When you type R, it will bring R for you, or a list of programs that start with R. Then you scroll through to get the R you're looking for. Double click on it. But when we go and open and open our R terminal, I think, like I told us before, this is what we're going to get, and this is not too user friendly for us. So for that reason, who will not use R will be using RStudio. To open our RStudio, the same thing. You go to your left hand side here, click there, type RStudio, or just type R and scroll down to get your RStudio. But if while installing your RStudio, you've checked a particular button that's to asking you whether you should install a shortcut on your desktop, and you said yes, now you could have the shortcut of RStudio on your desktop. Double click on it and R will be launched. RStudio will be launched. When you launch RStudio, you will have something like this. Now, initially, what you will have is this. This is what you have. Now here you can see that I have three major areas. Three areas here. On this left hand side, you can see what I have is a single pin. Now here I have one up, one pin up, I have one pin down. When you come here, all you just need to do, you will see some boxes here, some tabs. Click the tab that separates into two. Once you click it, you see this will come up. Now, if you are loading your RStudio for the first time, here will be empty. You will not have anything here. It will be empty. It will be empty. What you will be seeing, nothing here. The same thing here, all you'll be seeing is the version of R that you are loading. Now, let's get familiar, first of all, with this RStudio interface. Like we've already said, we have 4 pins or 4 quadrants. Let's look at this first one here on the upper right hand side. This is where we write our scripts. Scripts are instructions we give to system or computer that they don't execute immediately until we ask them, we give them the instruction to execute them. But as you come up in R, you understand scripts more and more. So just note, scripts, you write scripts here like you write in your MS Word, type anything, but there are some places you will not give specific type of instruction. Now, down lower part here, you will see this is what we call the console. You call it console. Now I'm moving my own. What you just do to move it around is that you click this middle part of it. You show you an arrow, then with that you can move it around just to expand and to collapse it. So now we have console here. You can see we have 3 terminals. We have 3 tabs: console, terminal, and jobs. But the most important thing to us for now is the console. When you click terminal, this is what you will see. Almost the same thing like our R terminal or R console. Then this place, it will be displaying when R is running a particular job. You will see that job here, but you don't need that. The major thing we need here is this console. This console is where R executes every command that it gets. Just note, that is where he carry out every command that he gets. He evaluates it. He executes it. That is where R outputs his command in the interim. Note that. And let's come to the right hand side here. On the right hand side, you can see also we have 2 panes, upper one and the lower one. Now let's go to the upper one. In the upper one, you can see we have different tabs also. Let me expand it for us so that we can see also very well. You can see here we have the environment. In the environment, it will be giving us what is happening or what we have done so far. We have history. History will list all the things that we have been doing all along, so that we can go through. If we have lost anything we want to see and we have not saved, we want to look at it. Okay, this is what I did here. That is history. Just give know what history means. Now, connection is just internet. If you are connected, you are with somebody out there, the 2 of you are collaborating. That is what they call GitHub. GitHub, normally researchers have GitHub account. GitHub account is where you store, it's like a repository where you store your codes, you store various things there. And if you want it to be public, it means people can come there, look at what you've done, look at your project, they can download your data, interact with it, get back to you. Just is meant for sharing, for collaboration. In that case, that is what connection majorly is about. And if you want to learn R yourself, look at this is tutorial. Now there's a package, we'll talk about package later, Learn R package, that is powered by RStudio tutorials. You can click, that will teach you R, Studio and other things yourself there. Now let's come down to this lower pane on the right hand side. Here we also have 5 tabs here. We have the file. If you the file is the one that is active, it will show you all the files that you have in your working directory that you have where where is active there in your home. Yeah, this is my home directory now. So it's showing me all the files I have there. Now this one you say plot. By and by, as we'll be plotting some graph charts, these are all will be displayed here. If you want to see them, just make sure you click this plots tab and they will be displayed. Now packages. Now R, like I wrote somewhere, it's like an endless ocean. There is no way you can only you can import everything about R. The system will crash. So there are packages that are not useful to you in quotes. Those packages will not come. There are packages that are almost useful to everybody, almost. So those are the packages that will come with the base R. Will come with the R that you install. So when you now need some particular packages, what you do, you have to go and download those packages from the server where they are. Bring them into your system. So when you bring them into your system, you can now load them whenever you need them. We'll be talking about packages more later. Help, if you need help about anything, this is where you get help. You can later how you go about help. The viewer, there's nothing much there for me to say onto us. Okay, let me go back to the slide. We have gotten familiar with RStudio. Yes, we've gotten familiar. We'll talk about now. We want to look at some R syntax. Pay careful attention here. R syntax is very important for us because by and by, that's what you will be using to make your life easy for you to understand some basic things about R syntax. Now, when you see this greater than sign, what is telling you, we call it prompt command. It's telling you, I am available. What do you want me to do? I am waiting for your instruction. Let's go to our R. You can see here, you have a greater than sign. And you can see the cursor blinking, waiting for me. What do you want me to do? Once I click anything there now, you can see, I can start typing whatever thing I want to type there. I can say boy equals to 55. I can say girl equals to 75. Okay, give me boy plus girl. You should give me 129. Now some of you, why do you, well, you said that you cannot perform calculation on two characters or alphabet. If you observe, I didn't perform calculation on those characters. I have assigned some numeric data to those to the boy and the girl. So R is not seeing boy as an alphabet now. Is seeing it that okay, this boy, what this boy means, this boy is holding 54. So I'm going to work with that 54. So that is what you should know. Now what brought me here is about the prompt command that you should know. That is what you call a prompt command, asking you what do you want me to do for you. Now assignments, this is assignment command or operator, less than and dash, less than and hash. It is used to assign some values to a variables, some values to variables. You can see here I said a card. I want you to put all these into a card. Put prof there. Put associate prof there. Put SL there. L1, L2, AL. And maybe continue to GA. Put it in a card. See, combine them together. If I now tell R, okay, R, give me a card, it will display what I've, put, what I've declared to be stored into a card. If assuming, let's go to our RStudio. I've not declared a card here. I just type occurred. Say enter. Can you see it's telling me error? Error. Objects occurred not found. There is not. I have not declared occurred, but let me declare occurred here now. For example, let's say occurred, and let's say equals to okay. Let me just say yes, occurred equals to prof equals to prof equals to SL equals to L1, like that. Okay, let me now declare occurred. Remember, initially it told me that occurred error, object occurred not found. Let me now say okay, R declare occurred. Give me what occurred is. Can you see? It's giving me prof associate prof SL L1. That is assignments for you. You know, I've now assigned that. I believe we understand that now. Okay. Okay, the same thing I've tried to do here. That's now it's not only this less than and dash that we use to assign. We can use equals to also. You can see here, I said C equals to 30. And when I said okay, A now is equal to A B plus C. Remember, I've said here that B equals to 10. When I say B plus C, definitely it will be 40. When we go down later, we will see it. You will see it there. However, you don't use equals to Y because the convention is less than with dash. But using equals to, you will still get the result. However, that is not the convention. So it is good we follow the convention. Okay. Now you can see here that when I say what is A, you say A is 40. Remember, what do we say? Why is A 40? We say A equals to B plus C. That is 10 plus 30. I hope you get it. Now, we say B to power 2. B square. What is B? Our B is 10. So B to power 2 is what? 100. So you see, it's declaring it for us 100. All these things, if you come here, you can try your hand out here. Let's come here now. Let's say B. We assign B to be 10. Is it 10? We made it there. Let's see, please. I'm sorry. Yes, B is 10 and C, we said C equals to 30. We said C equals to 30. We are now saying that A is what? B plus C. When we say give us A now, it gives us 40. We say, oh yeah, give us B to power 2. You can see, it gives us 100. Give us C over B. It gives us 3. That is 30 over 3. So you can see how we are performing mathematics with our studio. So you now understand what we mean by the assignment operator there. Now, subtraction, you just use normal minus, that is subtraction. For addition, is plus, normal plus that we use. For division is this forward slash. Then equals sign, equals, double equals to, that is equals. What it means is that you are saying, it's more or less asking R to help you dictate. Is A and B equal? Are they equal? It's not assignments now. You are asking. It's like saying, is 50 and 100 over 2 the same thing? Yes. 50 is same thing with 100 over 2. Because 100 over 2 is 50. So that is what you say. So 50 equals 100 over 2. Is it true? Yes. You can see that is what R is telling us here. It's telling us here. We say, okay, our A equals 50. Our B equals 100 over 2. Then our C equals 2 over 100. When I say, okay, R, A, is it equals to B? He said, yes. Because 50 is the same thing as 100 over 2. When I said, okay, is A equals C? He said, no, false. Why? Because 50 is not equals to 1 over 50 or 2 over 100. We ask it again, is A less than B? He said yes, A is less than B. Is A greater than B? He said yes, A is greater. A is less than B. Let's see. That's A here is 50, and there must have been something I omitted there, and I try it out with C. So that's that. Now greater than or equals to, look at greater than or equals to, use greater than equals to, that is what you have here. Greater than or equals to, here is that B is, or C is less than or equals to B, and it's telling us, so it's giving us all that. Now characters or strings. In characters which are alphanumeric, they cannot be used for calculation, and they are always enclosed in quotation marks. You should note that. You can see I say, okay, put the value a training on R to be equals to T for me, and put the value Yinka is organizing to be equals to R, to be equals to Y rather, for me. Now this and this cannot be added together. That is, we cannot add T and Y together. When we do that, we get an error message, because they can't be used for mathematical operation. But we can combine them together. Concatenation, we can combine them together. That is what this one has done here. I say, okay, RT, give it to me. Combine Y and T. Remember, Y is Yinka is organizing. T is a training on R. So you can see it can combine the two, but it cannot add the two. Okay. So okay, concatenation, like I've said, bringing them together, joining everything here together. You can see, this C here is concatenating all this together. Hold it. It's like cement holding the blocks together to form a single house. We are saying students is the house. Students is bringing everything together. Who are the people that comprise students, that makes up students? We see these are the ones. Okay, what are the things that make up scores? We say their scores were just 80, 75. So like that. This is what we have there. So concatenation, you know that. Now, for every open bracket, there must be a corresponding closing bracket. If you have 50 open brackets, definitely there must also be 50 closing brackets. So for every opening bracket, there must be a corresponding closing bracket somewhere. Otherwise, there will be an error, or R will tell you, no, this code is incomplete. There is something missing. Now, let's try out that here. Let's say on days, I said make it to be what? Make it to be Monday, be Tuesday, maybe Wednesday, let's say to be Thursday. Okay. Now let me say off days. Let me make it to be Sundays, Saturdays, make it Fridays. Now let me see, I forgot to add this closing bracket. Click enter. You can see the plus. It's telling me no, it's not complete. Something is omitted. If that thing is not added, I will tell you no way. You have to complete that thing, or you escape it. So once we add our closing bracket now, click enter. You can see the next prompt will come up. Okay, it settles that. So that's that about opening and closing of brackets. Now, using R syntax. Now, we should know one thing. R is case sensitive. Small letter R is not equal to small letter, is not equal to capital letter R. Small letter A is not equal to capital letter A. Let's see here. Let me see. Small letter A equals to capital letter A. It's telling me false, 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 never. It's not true. It's never true. You can see there. So R is case sensitive. Small letter and capital letters, they are not the same. So writing Ibadan with the first one to be starting with capital letter is not equals to small letter Ibadan. No, they are not equal in R at all. Okay, let me see the next thing that we would like to look at. Now, launching RStudio. Yes, I've discussed about launching RStudio. Now, I was saying something about packages, and I've told you that packages are, they are related functions. They are functions that, they perform related things or in one particular feed. So they will come in a package. Some people will sit down and develop that package. Now, there was a particular project we were writing on COVID, and I was to draw the map of Nigeria to now insert the various COVID-19 cases in various states in their in each of the states, give them the value. Now, there was a particular package, definitely for map, a lot of packages for map. So I was using the map for the world, but it was giving me a problem. I couldn't get states in Nigeria, local governments in Nigeria. And later I stumbled on a particular type of package that is specifically meant for Nigeria, Niger R, specifically. That package can be used to draw Nigeria map, to draw each of the zones, southwest, northeast, northwest, south, central, and to draw each of the local governments. But that cannot be at the world level. So various packages are developed specifically for various things. If you now need those packages, you look for them, get them. First of all, you will install them inside your system. After installing them, that you have installed them does not mean that they are available to you. You have to load them. Now, that is why you will see here, you see what I did. I said install .packages dplyr, and I'll say, okay, now library. That is library dplyr means load. Yes, you have installed these packages. So these packages is now inside your system. But for me to need it now, I need to load. So the library, everything inside those things, inside this dplyr, like it's a library now. Okay, bring up that library for me so that I can consult it whenever I need it. I can consult this one, I can consult that, all those things in dplyr, I can consult them. If I don't load it, there is no way I can have access to them. Let's see it here. Now, if you look at the lower right hand side of your RStudio, look at you will see various tabs here. So look at the package tab. When you click the package tab, you can see user library. For us to load any of these packages when we need them, all we need to do, we just click. You can see it will load it for us. You can see loading required package. It has loaded it for us. If I need this BH, I just click it. It has loaded it for us. Rather than me saying library, rather than me typing it myself here in this console to say library gg plot 2, for example, and I say enter, RStudio itself, once I click it here, it will load it for me. I believe you get you're getting what I'm trying to explain there. Like one of our person here now, who is an epidemiologist, is into epidemiology. Now there's a tool called EpiTools. EpiTools. Now EpiTool is not here. Let me search for it here and see. Let me just type. Okay, is it in my library here? You know what the packages I have installed. I search EpiTool. He said no, it's not there. So if I want to install it, what do I do? How do I install EpiTools? Look up here. I will come to this place. I'm still on this tab package. I come to this place. You can see install R packages. I will click this install. Once I click it, this window, pop-up window will come up. I will now type EpiTools there. Once I type EpiTools, what happens? The next, I will now click install. Let's see. You can see it's loading it for me. It's going. Now watch here. You can see this place. You can see there's a red tab here. It's telling you that R is busy. You cannot enter anything into this console until the function what is doing at the moment is completed. It cannot accept anything again. Then you observe here that the command prompt is no longer available. So until R complete what is doing, this command prompt can no longer be available unto us. It has to complete it. Now R has completed it. So you can see we have our EpiTools. So I can load my EpiTools. I have to go search how to use it, search the functions there, and start using my EpiTools. So that is how we load package. We install package. After installing the package, now if you need it, you just click in front. You can see it has loaded it for me. So I have my EpiTools in my libraries now. No documentation for EpiTools is specified in the package and libraries. So you can see, okay, when I take time to go through that, you see. So that's how you load your package. Let's continue with training. Okay, now for us to use R to analyze our data, the first thing we need to do is to read in our data, to import our data from wherever we've stored the data. We've arranged the data, let's say in an Excel, for example. We put our data in an Excel file. First of all, we read it into our RStudio. After reading it, let's take, for example, let's see how we can load in a data from our Excel file. Now you can see my prompt is here. Now come up here, look at file. You see file here. You click this file. When you click this file, go down. You will see import data sets. Now the data set I want to import, what type of data is it? Is it a test data? Maybe in Microsoft Word.txt. I will click test base. If it is what we call CSV, that is comma separated value, I will click this one. Now if it's from an Excel file, I will click this. If it's SPSS file, SAS file, Stata file, I will click the corresponding one. Now what I want to load in is an Excel file, so I will click Excel. Once I click Excel, it will bring this pop-up window for me. The next thing I do, I want to browse to the field, to the location of my data. Now, before I go to that, you can see under here, where you can see my cursor here, you can see that R is doing some work for you behind the screen. RStudio is doing some work for you. These are the things you ought to do yourself. That is the beauty of RStudio. So it will relieve you of some work that you should have done yourself. So you load this for me, load that for me, but you don't need that. I'm just trying to bring that to your knowledge. So when you get here, you browse to the location of your data set. Now, where am I going? I want to my the data I want to load is in R training. Let me go to my desktop. Okay, my R training. Okay, yeah. Okay, now I want to load in this data set xlx.sls data Africa virus. This just contains some data that we were analyzing about the virus in Africa. So I click it here. I now click open, depending on what you have on your own system. Just like you browse and open your data wherever, that is what you do. When I click open here, it will bring me back here. You can see it now. I can see a preview of my data set. Look at the first one. It's giving me the region: South Africa, Morocco, Egypt. This is what my data look like there. I will go and open it for you to see. So I will now click here, import. That is it. It's already in R. R has imported my data set for me. Now, if you look here, you will see it's Africa virus. Read this. That is what is reading for me. So it has read it. It's inside my R now. So if I type African virus, yes, it will locate it for me. I don't want to do that yet. Now you can see that on this script pane now, it gave me a view of my data. Now, if I want to go back to where I was before, there is a tab. The tabs are there. I have various files open there. I'll just click the file that I was using before. It will open. If I click module 1, you can see I have this. If I click this, I have this. If I want to close that one, I'll just click close, and that one will go. And I want to save it. No, and that one will go. Just close it. Okay, so that is it. So let me come back here. So this is how you reading your data, your own data set. This is how you reading your own data set. I want to believe every one of us can do that. Let me go over it again. This is a video. You can pause it, rewind, go over and over again. So you come to File, you narrow down, you go to your, if it's from an Excel file, you click Excel. If it's test, you click test. Anything is here is an Excel file. I click this Excel. It brought me here. I want to browse. If admin is an online, it is online. I will type the URL here, and it will go there. Now it's in my own system. I browse to where it is on my system. It's on desktop. I click desktop. It's on R training here. I click R training. Is inside this module 1 intro. I click it, and this is what I want to do. I go there. No, it has brought it out for me. This is the parts. So I click import. Once I do that, yes, I have my data in R. And from here, I can start doing some work on my data. Now, my data is saved as Africa virus. If I want to change the name to anything that suits me, what do? I will use this up arrow. Use this up, there's up arrow on your keyboard. Use the up arrow to go up and down. If I use the up arrow now to go to that last command, I will use the side arrow now to go back, the back arrow. Not the back space, the back arrow, but we have the up, the down, these two sides, right and left. So I use the left arrow to go back here to where I have my Africa virus. I can say COVID virus, COVID-19 virus, SARS-CoV-2 virus. I can write anything I want to write as my new the name I want to use to save my data. Let me say I want to call it coronavirus. Once I write that coro there, I can save it. No, it's saved already. I hope we get that. So Whenever I ask give me coronavirus now, it will display all this data for me. That's what R will display for me. Now, let's assume somebody sent you this data. It's not your own data. Somebody sent the data set to you. You want to understand the data set, what it looks like. What you really want to go through Excel to see what it looks like in Excel. You want to use R here to see what the data set that was sent to you, what it looked like. There are various operations or functions you can use. First, we can use summary. Let me say summary, then I say coronavirus. Enter. You can see what it's bringing to me. It's telling me regions. We have 57 regions. So there's a column called region, and there are 57 there. But what class of character is there? What class of data type is there? He said it's character. Now, the next one I have there, he said it is SARS-CoV-2 cases. He said the minimum value there is 10. Tell me, first quarter there, he gave it to me. The median value there, he gave it to me. I hope you are saying what I'm. So you can see here, this is the minimum value. He gave it to me. This is the first quarter. This is the median. He gave it to me. This is the mean. This third quarter. This is the maximum value. Now, for each of the what do I call it? For each of the numerical data now, it will give that summary to me. So now I can see, okay, if I want to plot anything now, I know the maximum value, I know the minimum value, I know the average, I know the median. That could be of help to me. It may not be of help to you yourself because you're not a statistics person, but those in statistics, it will be of help to them. Summary. Now, if assuming we just want to know the structure, that's what they call STR, structure. You just say structure, then you put inside your bracket Kuru, that is the name of your variable, that is structure. It's telling me it's a table structure, table data frame. What do we have there? We have a particular column named region. It's in character form. The first four values there are South Africa, Morocco, Egypt, Ethiopia. They give me, okay, SARS-CoV-2 cases, population, total, and all the data we have there. Now, let me say, if I don't know the names of those, how do I know? I just need the names of those columns, the names of what we have there. I just say names, coronavirus. You see, you just give me the names of each of the columns we have there. That was given the name of each of the columns. We have column 1, region, followed by SARS-CoV-2 cases, followed by population, total deaths, this and that, then total test, and all those form of, it's just telling me what's the name of each of the column. So with this, you can work, okay, I need this column, I need this. You can do what they call subsets and all the rest. Now, there's what they call dimension, DIM. DIM, what do I type? I just type DIM, Kuru. It's telling me there are 57 observation in 10 variables, 57 rows, 10 columns. So there are various things that way that it will throw up at you. Many of them, as time goes on, you will get to know various exploratory data sets, data functions that you will use to explore your data, to have an idea of what your data is, just to get a summary, statistical summary of your data set. Let's go ahead. What else would I like to mention again? So with that, we can do some little valuation here and there, and then draw my graph. After drawing my graph, I will export my plot. Now, I want to do something here. Now, what I want to do, this data now, we don't have it. All of us don't have it. So because we don't have it, it can not be useful for us. We can't use it to perform analysis because we don't have it. But I just try to use it to explain to you how you can import your data. Now, let's assume you want to copy that data so that it can be easy for you anytime you want to use it again. Maybe you want to save it in a script, in your script up. You just highlight it the way I've highlighted it. You control copy, you come to this up here, just by the way, and say control paste, and you have it there. You can just work on it and all the rest. Now let's use some of the data say that we, irrespective of where we are, we can use them. Now we understand how we can load in our own data. And if assuming we load in our own data, we have our data with us. What are the things that we can do with our data using base R? There are many things we can do with R. We are not going to touch everything. This is just a basic class. So it's going to talk about base R. The next class, for example, is going to be like an intermediate class where we'll talk about ggplot2 now, which is specifically meant for what? For visualization. Plotting of beautiful graphs, various graphs that will bring out a lot of things. ggplot2, then dply, talking about how you manipulate your data. Instead of you doing some of all those calculations in Excel, inside dply you do those manipulation, remove some things, mine something, pipe, and all the rest. Now, we want to now, so that's by the way. So I'm just trying to tell you that we can't do everything here. It will be too much. So we take it little by little. We are using only what we have as base R, the little thing that the base R, the basic R can do. That is the things that we will be looking at in this our module 1. Now, there is a data set in R that is called women. This data set contains the heights, the average height and average weight of some American women. That is what it contains. Just like we have loaded in our data now. You've seen how to load in your own data. So you can load in your own data and start doing some work on it. But for uniformity's sake, for teaching purpose, and for us to try our hands and see things together, I'm using data sets that are inside R. So let's run this code. Come up here on the scripts panel. Now you highlight this women. Before I go there, now all these ones you see up, that is if you have opened the scripts I sent to you, the arrow script I sent to you, if you open it, you will see this. This is what you have there. All these hash keys here and these ways here, we call them commented ways. So it's telling R that R, this is not meant for you to perform anything. It's not meant for you to do anything. This is meant for the humans to read, to understand one or two things. So R, ignore all what you are seeing here. It's only the ones that don't have hash key beside them that R will evaluate. So you go to this first one, women, highlight it, and come up here, you see run. Click that run. You may have observed something has happened in the console. It has evaluated what we gave it. Alternatively, bring your cursor either in front. I insist you bring it in front and not here, so that you may not mistakenly just type enter, hit enter before you hit control. So if you do that, definitely you will have disrupted this and you may not get it easily, except you are conversant with the system and know how to just bring it back easily. So bring the cursor in front of this woman here, then press your control and hit your enter key. Once you do that, that thing will be evaluated. Now, just like we loaded our data initially, and we say this data equals to what? Coronavirus or SARS or anything, depending on how you name your own data set. The same thing, we have loaded a particular data. We now stored it, store the value into women. Now we want to look at what we have in that women data. Remember we did summary, so we can type this summary either down or just come up here, highlight it, and click run. You can see what it's telling us, just like what we have the other time. Talk about the minimum value that we have underweight is 58, telling us the first quartile of the people have 65, 61.5, and all the other statistics. Okay, we want to say, for example, let's see what is the structure of that data that came to us. Remember when we talk about structure, initially we talk about data frame, talk about vector, we talk about matrix. So there are various type of data structures. So that's what we mean by structure here. So when I say give me what type of structure is this, highlight, run, or control enter, it's telling me it's a data frame. It contains 15 observations and 2 variables. What are those variables? Height, which is numeric variable, and weight, which is also numeric variable. It gives us that. Alternatively, we can just look at, you can see dimension. Dimension will not give us everything. It just tells us that there are 15 rows and 2 columns there. Now, let's assume we want to check the mean of the heights. What is the average height of our data? Now, you will type what? Now, there's what they call subsets. Subsetting means, okay, I know there are many data inside this my data set, but this is the particular column that I need. Is this column you should give me? Once you have saved your data, or you have stored your data into a particular variable, you can access any part of that data. What do I mean? Look at, let's say women. Now we have a data that we have loaded as women. This data contains 2 columns, height and weight. We want to get one of them. So after typing that women, what we do now, we just type $sign, $sign. For my own key, it is Shift and 4. Give me the $sign. Once I type the $sign, I will now select or type the column that I need. I need height, for example now. That is the height. If I enter that, it will display just the height. Can you see? It will just the height only. It will declare for me. Just the height. You can see now, this is like a vector. If you remember what we talked about, vector. This is just a vector, is one way. The same thing, women, give me the weights now. Give me the weights of women. You can see, this is the weight it's given me. Let me go to my Koro, which is like our own data. We have region there. We have various things there. Let me choose region. If I enter it, can you see? It will bring up all the regions. Every cool thing in that region. Koro. Give me what now? Give me population. Just population. It will list all the population in that field. I want to believe we are following. Like I said, you can pause the video, go back, over, understand it, proceed, and all the rest. The essence is for you to understand it clearly. Now, let's come back to the data set that is universal for all of us, which is women. Now, women, I want to get the mean of the heights. The mean of the height. I said mean. Mean is an operation already. I type women. What you are performing an operation on will be inside the bracket. The operation you want to perform will be outside the bracket, except you want to perform another operation on that operation. Don't worry, we will get there. So we look at, we are looking at the mean. We want to look at the mean of the height. The mean of the height. So look at mean, where we are subsetting is height. We now say give us the mean. It says the mean is 65. Let's go for the mean of the weight. They said the mean of the weight is 136.73. That's it. Okay, let's proceed. I want to believe that we are following gradually. Now, I want to plot. I want to get a plot. Now, I say R, just give me a basic plot. I say plot, women. R, I just gave it women. Now, remember in women, we have two columns, weight and height. I just say R plot. R will say, okay, Siri instruct me, you didn't give me a clear instruction on what and what to do. I think this is what you are trying to do. We now just put weights for me on the x-axis and put height on the y. Sorry, you put weight on the y-axis and put x on the and put height on the x-axis. Now I could have instructed it also that no, I want my height to be on the y-axis. Why the weight should be on the x-axis? In that case, I have to be explicit. I have to go further. I have to declare more argument to give out more instruction. Let's let's give an example here. Women. I can say, give me x to be equals to women x to be equals to women weight and y to be equals to women height. And I say, yeah, plot it for me. You will see that it has changed the orientation. Now you can go back and forth of your plots here. You click back. Now, in case you can't see your plot, it means that your plot tab is not active. It's another tab that's active. So you click your plot tab so you can see it now. That's how you see. Now you can see that I'll now make the title of my x-axis and y-axis the particular value I gave it. But that value is not making sense to be the label of x or y axis. Then I have to specify to R, no, R, this is how I want you to do it. I'll now say, okay, the x lab should be what? X lab should be weight in brackets. I say weight, and I put and I say, okay, make the y lab will be equals to what? Height in centimeters. Okay, let's enter now. What happened? Oh, now you observe something now. The data set is incomplete. So let me go back and complete it. So it's done it for me. But you can see I forgot to put a space in between my weights and the units. So I can go back using my up arrow, then scroll back there. Let there be a space there. Come back here. Let there be a space here, and click my enter. So you can see now it looks better. There's a space now. Now I didn't put what do you call it, title, and I want title to reflect on my plot. So I can come here, put title. If I want to put title, I say main. I put my title, width versus height. You can see. Oh, sorry, I said Heinz. So I remove the N. And that is it. Now I want to save my plots. I want to save my plots. I want to export it to where I want it to be. How do I do that? Now come up here. If you go up here, you see an export tab here. You will see a drop down export tab. Click on that drop down. Now I can save my image as a JPEG or picture file. I can save it as PDF. I choose which one do I want. Do I want to save it as an image, a JPEG, PNG, or I want to save it as PDF? Let me choose PDF for example. I say, yeah, save as PDF. It's not asking me, do I want to change the size of my charts, or I should maintain this one that is here? Do I want to make it portrait, or I should leave it in landscape? I can decide what I want here. Then it's asking me what is the name I want to save my, this is here now. It's asking what is the name I want to save my file as. I can say weight of women. Weight, just see women weight. Once I do that, I click. Now I can choose which directory, where do I want it to save my the image. Where do I want the image saved? Where specifically? I can, from there, once I click that directory, I can come to the where I want RE training. So I can say save it here. See, you can see it has taken me to that directory. I can now come here, click. See, if I want to have a preview of what my graph look like, this is the preview of my graph. This is a preview. You can see that's a preview of what my graph look like. You can see it here. So let me close that. I can now click save. Once I click save, it will go and save it where I have that my image. I want to believe you have followed very well. Now you may not bother yourself so much about this. Now here, forget about this JPEG and def. Actually, what it is doing here, instantly it will go. Now rather than me clicking do this, do that, do this, do that, it will take it straight. Say for example, once I highlight everything like this and I say run, in fact you will not see the thing expecting me to go and save it where it should be. It will go itself. Why? Because I have declared the paths of where it should be saved. I have said inside this working directory, save it under image. Under image now, let the name be width height .jpeg. So it will open this for me, plot it, then close it for me, save it where I want it saved instantly. That's done. Let me try it. You will see. Let me change it, and so that you just understand. Let me say Olayinka, American women. American women. American women. Let me just now say I will highlight everything. Make sure I highlight everything, and now run it. Could open file. Let me see what's happening there. Let me go back. Let me see the image. Okay, what is my working directory? Let me get my working directory. Sorry, my working directory. Okay, my working directory is home Olayinka. Okay, now where I have that image is under home, the desktop, arrow training, desktop arrow training, images. Okay, desktop arrow training, images, home Olayinka, desktop. Okay, let me just set my working directory. Set working directory to home slash Olayinka slash desktop slash, let me see, desktop, from desktop to arrow trainees, module 1 to arrow trainees, arrow trainees slash module 1. You can see as somebody who is coding, who doesn't want to do all this other thing, you have to specify everything. Module 1 intro, module 1 iPhone intro, then images. Module 1 iPhone intro, images. Module 1 iPhone intro. Okay, let me just stop at module 1. Yes. Ooh. Set WD. I typed double D instead of a single D. It was double D, so that was why it gave that. Cannot change working directory. Why can't it change my working directory? Cannot change it. Home, from home to desktop, from home to desktop. Okay, from home to desktop, not Olayinka, it's not there. there is something wrong somewhere. Okay, I will search out that what could have gone wrong.